Hmm. Good morning. It's right before 8 a.m. But I figured I should just do it now. Get some get some programming in as like a little warm up for my day. Um, that's also I just want to learn some C. It's gotten me all excited because we're actually making good progress, I think. Anyway, let's continue. So we're talking about the Bermuda Rectangle now. I think it was like 2 days ago we were trying to parse out. We created a tool to parse out CSV to JSON, and we had actually a bug that had I think it was like a latitude that was way too big, and so we modified our program to account for that and output it to SCD error. So now we have a new requirement here that, okay, so instead of looking at the whole world, let's look at the Bermuda Rectangle, where our latitude is limited from, what is it? Anywhere from 26 to 34 and it's negative 76 to negative 64. So that creates like this little square here. Okay, so where do we need to begin? So the requirement here is that we can't change our CSV, in this case geo to JSON. We can't change our current tool. So our geo to JSON tool displays all of the data it's given. So what should we do? Should we modify the geo to JSON so that it exports data and also checks the data? We could, but remember, a small tool does one job and does it well. So that's the one thing we had to remember. When we create these little tools, we had to choose what is like the ultimate purpose of that tool and making it do one job and do it well to kind of stick with that Unix philosophy. So the book says you don't really want to modify the Geo to JSON tool because we want it to just do one task. So if we make the program do something more complex, we'll basically cause problems for our user who expects to keep the tool like working in exactly the same way. So like you could, if you modify a tool and you're not very considerate of what you're doing in terms of modifications, you can actually break some compatibility with the existing workflows that your users have actually used, like their workflows that they've created using your tool, right? So you could break back compatibility. So then when you modify a tool, you have to consider backwards compatibility. The second thing is that every time you add more features to a tool, you have to think about the user experience, right? So like how easy is it for a user to use your tool now? Now that you have yet another option or another path, um, you're going to have to consider whether or not it's going to be easier or just as easy to use. Um, you don't want users to have to kind of juggle between like like what how to actually take this path or how to take the other path. You have some like tools out there that have like 100 different like options and switches, and it's just like impossible to remember. And I just don't think those tools are very ergonomic for users, and so that's like another reason too. And another thing is just for you, right? As a developer, having a tool that does way too many different things, it just makes it harder to maintain. Like if there's a bug that happens in the tool, well, yeah, you spend more time looking for where that bug is, in terms of debugging, and also you can introduce a regression with all the other features with it. Whereas if you have one tool that does one thing and does it well, and maybe you have a suite of tools coming together that kind of fulfills a specific workflow, if there's a bug that happens in one of those tools, you can have like a smaller scope in terms of debugging, right? And the chances of you introducing a regression or like a bug into other tools are quite low because you didn't really touch those tools. So anything that really happens, like if a bug comes out of a workflow, right, you can kind of attribute it to your tool that you modified. So yeah, those are some of the advantages of having a smaller tool, like really. Anyway, so if we don't want to change the Geo2JSON tool, what should we do? Oh, and here's like tips for designing small tools. So basically, you always want to read from standard input, display the standard output, always prioritize in dealing with some sort of readable text data, and then just perform one simple task. So anyway, so we can consider like this Bermuda rectangle thing to be like a different task, right? So if we have a different task, doing one thing means that we need a different tool. So if you want to skip over the data that falls outside the Bermuda rectangle, you should just build a separate tool that just does that. So basically, we're going to create like a tool that sort of filters, like given like all this data here, we're going to like slowly, like not slowly, we're going to filter out any of the entries that are not within the range of the Bermuda rectangle. And then those lines are going to go into our CSV parser to JSON, and then we'll just only output um, like longitude, latitude, or I guess data points that are in the Bermuda rectangle, like inside that square, in JSON format. So yeah, so that's like the flow, right? This is all this data coming in is basically any sort of data point, any longitude, any latitude, any speed, feed it into the Bermuda tool, then that will like only output things that I guess are inside the Bermuda rectangle. It's still CSV, right? And then it goes into our CSV uh, to JSON tool, and then converts that to JSON, converts all the Bermuda rectangle entries into JSON. So how do we connect the two tools together? Well, basically, we're gonna probably use pipe, right? So we've used pipe in the past, and that's how we connect two tools together. You take one tool's output, and then you feed it in as input to the second tool. So yeah, so we connect our input and output with a pipe. So you've already seen how to use redirection to connect the standard input and the standard output of a program file. But now you'll connect the standard output of the Bermuda tool to the standard input of the Geo2JSON like this. So all the raw data, again, all the raw data points coming in as CSV line by line, going into the Bermuda tool. Then our Bermuda tool will then filter out only the points that are in that rectangle. Then we pipe, right? Because all the output is going to come out, but we pipe that, connect it to basically our CSV to JSON parser to actually then convert everything to JSON. I'm just like reiterating so that we understand. The pipe symbol is a pipe that connects the standard output of one process to the standard input of another process. So the output of the Bermuda tool becomes the input of the of the Geo2JSON tool. Excuse me. All right. So then now, that way, whenever the Bermuda tool sees a piece of data inside the Bermuda rectangle, it will send the data to its standard output. The pipe will send that data from the standard output of the Bermuda tool to the standard input of the Geo2JSON tool. The operating system will handle the details of exactly how the pipe will do this. All you have to do is to get things running is issue a command like this. So again, execute Bermuda. Bermuda is going to output stuff, and we're saying, okay, wait, don't do anything with this output except just pass it in as input to the Geo2JSON program. So that's what the pipe does. So it's time to build the Bermuda tool. Okay, so the Bermuda tool. The Bermuda tool will work in a very similar way to the Geo to JSON tool. It will read through a set of GPS data, line by line, and send the data to the standard output. But there will be two big differences. First, it won't send every piece of data to the standard output, just the lines that are inside the Bermuda rectangle. The second difference is that the Bermuda tool will always output data in the same CSV format stored in our GPS data. So again, all the CSV data that's coming into the Bermuda tool, we do that filtering, right? If it's inside that rectangle, and then output is still CSV. We don't do any format conversion. We're just going to pass it through. So in pseudocode, and that's a hint. Let's make a project. So let's do this. Let's create something called Bermuda. And then we'll create a main.c. And let's kind of clean up a little here. Okay. We'll do pound include sdio.h int main int argc character pointer argv array. So all our arguments return 0. Okay, so that's our template. We know we need that for our program. And let's read the pseudocode. So we're gonna we're going to read the latitude, longitude, and or I'll say etc. for each line. If the latitude is between 26 and 34, then if the longitude is between -64 and -76, then display the latitude, longitude, and other data. Okay, so that's the pseudocode, right? So basically, if the latitude is between 26 and 34, and it looks like, okay, well then we'll take this if condition inside, right? If the longitude is between -64 and, wow, that's like really weird math. I should just have said -76 and 64. Okay, so -76 and 64. Then we also display the CSV, like that CSV line, right? Of course, in code, we can simplify this to be an AND condition. And so we only have one if block, right? I think that's a good way to optimize. And then we can store these values as like variables, right? So they'll be like, this will be like min latitude, max latitude, min longitude, max longitude. And we shouldn't really use like numbers like out of nowhere. So we already have sort of like an idea of what to do. So how do we read for each line, right? So read the lines using, how do we do that? Is it f get s in this case? Right? So that's how we read every single line. And I think we in our previous one we used, was it scanf, right? Yeah, we use scanf on this one. Yeah, should we? Yeah, we should. Yeah, we could read f get s. We could try f get s, or because I think the reason why scanf was used because we can easily get formatted things this way. If is there like something that's similar to that can give us like this formatting? Is it maybe it's called fscanf? Maybe let's try it out. Let's see what we have because I want to get that same sort of like easy input parsing. that we probably wouldn't get with fgetS, because fgetS is just gonna put all the data into a buffer, and then we have to do like our own parsing. But this is like for free with scanf. So yeah, so like that's the one thing you need to think about, right? Like, read the latitude, longitude for each line. But like, okay, sure, we can read a line, but we had to know which one's the latitude, which one's the longitude, and the other pieces of data, right? And that's, I mean, we could do it without scanf. We could like try to like parse every single character and see if it's a number, and then which one's a latitude, which one's longitude. But I think that's just too much work for this project. I want to keep it simpler and be able to understand that everything's just separated by commas anyway. So I want to know if there's actually something called like an fscanf. So I'm just going to do man fscanf. And there is actually one right here, fscanf. So is that just for files? Oh, that's just for files. It's not. It doesn't stand for formatted scan, because I guess that's what the F here stands for. So a scanf. Huh. Okay. So scanf. It is very difficult to use these functions correctly, and preferable to read entire lines with fgetS or getLine and parse them later with scanf. Oh, that's so cool. So we can use fgetS. We said we had to use scanf afterwards to do the same effect. So we can actually get the same thing from scanf if we did fgetS and then followed by scanf, I guess. Okay, let's just keep that in our minds. So on success, these functions return the number of input items successfully matched and assigned. Okay, so we already know return value. Basically, for scanf, the return value is the number of elements read from your formatted string. But I want to explore f. Well, we know this is already. This is like here. I'll put this up. We know fgetS. fgetS here takes in, it looks like, the character pointer, okay, the size that we want to read into the character pointer, and then whether or not it's, I guess, standard in or some other file. I think that's the order. So yeah. So if we used fgetS on every single line in our CSV, this will have all our data. But what do we do with it, right? Apparently it says the other documentation for scanf says, well, if you're using fgetS to load up your string, you could use scanf to do that parsing. So let's see. Oh, here's something interesting about fgetS. fgetS reads in at most one less than the size of characters from stream and stores them into a buffer pointed to by S. Reading stops after the end of file or a new line. So again, it's new line delimited. If a new line is read, it is stored into the buffer. So that's the reason why every time when we use fgetS, notice how we always have that new line at the end, because it will always read that new line into the string buffer. And then the terminating byte, so the null character, is stored after that new line. Okay. Okay. Okay, and fgetS will return the string pointer. So same thing as like whatever the buffer is that we've inputted right into. Oh, that's weird. But yeah, it'll return that input buffer. Okay, so we know fgetS is to get our string. Now let's try to use scanf. Let's see what scanf means. Okay, so description before we look at how to use it. The scanf family of function scans formatted input according to the format as described below. This format may contain conversion specifications. The results from such conversions, if any, are stored in the locations pointed to by the pointer arguments that follow the format. Each pointer argument, so you provide addresses as arguments. So this is starting to sound like scanf actually. So each pointer argument must be of a type that is appropriate for the value returned. Okay, so this is exactly like scanf. If you want to read in a float, you have to give a pointer to a float. Okay. Then basically scanf will load that input into the location memory corresponding to that float. So it's the same thing. But the thing is that now you have the first argument is that string that we read from fgetS, and here this one is the format of the string. So like the same thing that you had passed in to scanf, right? So now you're like combining it all. And then after that is all your arguments, the floats or the strings or whatever, passing in the addresses so that it can load into the variables, the values to the variables. So it looks like that is the gist, right? So we stopped that each pointer argument must be of a type that is appropriate for the value returned by the corresponding conversion specification. And then we know if the number of conversion specifications in format exceeds the number of pointer arguments, the results are undefined. So we provide less arguments than our format, then we don't know what to do. If the number of pointer arguments exceed the number of conversion specifications, then the excess pointer arguments are evaluated, but otherwise ignored. Okay, so then if you have more pointer arguments than your formatted string that you pass in, then it's just going to ignore the excess stuff. Okay, and then so the format string consists of a sequence of directives which describe how to process the sequence input characters. So it's like similar to scanf. If a processing of a directive fails, no further input is read and scanf returns. A failure can be either the following: input failure, meaning that the input characters were unavailable, or matching failure, meaning that the input was inappropriate. So basically, the way you format is that you could have, let's see, you can have spaces, tabs, and new lines. You can have normal characters. Okay, and then you could have your typical percent stuff. Okay, this looks like normal scanf stuff. Okay, let's just try it out. We can just read it whenever we run into issues. Okay, yeah, this is okay. Yeah, it doesn't matter. Let's just use it. We know it's kind of like the same. So, okay, so let's do it. Okay, so read the longitude and latitude. And okay, so now we need to get the line, right? So how do we get the line? We use fgetS, right? But in order to do that, we need a buffer, right? So we'll declare a buffer array, right, that has 80 characters. And then we're going to basically call fgetS with our buffer, the number of characters, which is going to be exactly what we declared in our buffer because we automatically get the null terminating character, and then also std in. Okay. Now, once we have our buffer, we're going to use scanf. And the input for this one is basically the address to the buffer, the pointer to the buffer. Since arrays are just, the labels of our arrays are already automatically pointers, that's fine. And then our format, which is going to be exactly like how we did with scanf. So it's going to be %f, comma, %f, and then I think it's was it 79s, and then what was it, like excluding the new line character or something like that? Was it, how did they do that? This one, this thing here. Okay. I guess we don't need S. We just need this. Okay. And then our arguments, right? So we need to declare some arguments. So we're going to have something that stores our floats of latitude, float longitude, and then we'll have our buffer can be our data, right? No, can it? No, that's our string. So our buffer, so it will be character data, and that will be also 80 characters. So I realize that this needs to be a little bit more now because our data could potentially be 80 characters, and then our line is going to be way more than that because this could be 80 characters, but now you have to consider all this stuff here. So I'm going to give this instead double that. I'll just say 160 characters for the line. So we should name this better. Instead of buffer, let's name this CSV line. CSV line, because that's different from the data. Right? Our data is going to be this one here. Our longitude is this one, our latitude this one, but this whole thing we're reading in is going to be the CSV line. So that's how we're going to read that. Then we're going to pass the address of the latitude because that's what we want first. The latitude of the longitude, or sorry, the address of the longitude, and finally our data, which is already a pointer. Okay. At this point, I'm not confident personally of this implementation yet, so I'm gonna print out what we've inputted. So I'm gonna print F, and I'm gonna print %F, %F, %S. So I'm gonna say our data. And I'm gonna do latitude, the value latitude, the value longitude, and then the character pointer, which is data. Let's see how this works out. And I'll print a new line at the end. I'm used to Vim. Actually, you know what? I'm gonna do this. Sorry, since it's like one day I haven't been in Visual Studio Code, I'm just gonna install the Vim extension. So got used to. I keep hitting escape for no reason, expecting it to do something. Okay, now we're in Vim mode. Okay, great. Okay, I can HJKL around. Okay, great. All right, so let's compile. So we go one directory up, and then we are going to go to Bermuda. We'll do gcc main.c. Okay, all good. Let's run our program. And then we're going to ask for input. So I'm going to say 42.3, I don't know, 55.6, and then speed is going to be, I don't know, 123. So that parsed correctly-ish. Of course, when we're turning things to float, we lose precision a little bit. But this is pretty much exactly what we want, right? We want that to be parsed correctly, and we did. And that's so cool because basically now we don't need scanf anymore. We can just use the combination of fgetS and scanf to get what we want. And it seems to me conveniently that if we look at this formatted string here, right? This formatted string here, that is exactly like what you would put in to scanf. So I think that's really cool because apparently the book is discouraging us to use scanf because of security and buffer overflow problems. But now we have a solution here. We can use a combination of fgetS and scanf to get what we need that we would normally have with scanf. We just have to remember here, right, that this is the line, not just the data itself. It's the line, meaning the combination of the latitude, longitude, and the data that's coming in the entire line that we're reading in. So we have to allocate enough data for that. If we're expecting, like, for example, data here to be 80 characters, we have to also account for latitude and longitude too, the string versions. And then we'll do the conversion with this scanf call. Anyway, so now we need to check if the latitude and longitude are within range. So that's easy. Before we do that, let's actually define some constants here. So some global constants. So we'll say this is going to be float max, or let's do min latitude. Latitude is going to be 26.0. And we'll do float max latitude is going to be 34.0. And then we're going to do float min longitude is going to be, what is it, negative 76. And then we're going to do float max longitude is going to be negative 64. Oh, we should make it a float. So I think we could do it like this, or we can do it like this. No, it has to be like this. It has to be like this to be a float. Yeah. Okay. So it's a simple if statement. So it says this: if latitude is going to be between 26 and 34. So what we're saying is if it's was it greater than? Is it greater than 26, meaning the min latitude, right? And right, latitude is less than max latitude. That means it's between. Okay, so that's one condition, right? So that's one condition. And then we can say, let's see, there can be an and here. I think we can just do this. Longitude, or I should actually have this. Longitude is going to be greater than min longitude, and longitude is going to be less than max longitude. Okay, and I think our parentheses are okay. Okay, so we have this long thing here, and let me kind of just like break it down. Does that even help? Maybe? Yeah. And then we'll probably break this down here. Like this. Yeah. That still looks kind of weird, but okay. We just basically want to check if the longitude and or the latitude and longitude are within that square. And so we'll display, meaning we'll print out the latitude, longitude, and other data, like the same way, the same format as the CSV, because that's going to be fed into our CSV to JSON tool. So we do printf, and we're going to do print float, print s, new line, and then it's going to be latitude, longitude, and data. Okay, straight up. So far so good. All right. So is that how the logic works? Let's check. There was like logic here. Right here. Latitude greater than min latitude, okay, and latitude less than max latitude 34, and longitude is greater than negative 76, and longitude is less than negative 64. Looks good. Okay, let's move on. Okay, so that's, we did one iteration. Oh yeah, while it is 3, but that's okay. That's fine, I guess. We just need to have a loop. So how do we do this? What does scanf return? Maybe we could do the same thing. So let's check scanf again, because we want to keep iterating until we don't have any more things, I guess. So we look at the return value. Is there a return value somewhere here? Or is this just more details? Return value. Okay, so scanf, the return value On success, these functions return the number of input items successfully matched and assigned. So it's very consistent with scanf. It's the same thing. Okay, so it's the same thing. So we're gonna, I guess we're going to have a variable int items read. It's going to be, or how do we do this? Because we want to keep receiving a line, right? So, how will we do this? How will we do this? Do we then just do, so if we did, let's say, while, so, oh, I get it. While, let's say this, items read, okay, is 0. And then we'll say while true, so, or not true, while 1. So we're going to create an infinite loop, and we're going to use a break to actually kill the loop if we have items that are less than 3. So we're going to do this. We're going to cut this in here. We're going to paste it, and then we're going to indent it a little bit, like this. And then we're going to then do items read is going to be returned by scanf, okay? And then we're going to have an if statement here, okay? If items read is going to be less than 3, then we are going to say break. Done. Otherwise, if we read 3 items, hold on, gotta check my phone. Okay, whatever. It's work stuff. Okay. So otherwise, if we have 3, we'll just continue and print, and then try to read again. So looks pretty straightforward. Let's test it now with this loop. In fact, we can compile, and then we don't have a good test for now, but it's okay. So let's do 23. What was the range? Actually 29, negative 60s in range, and then blah blah blah. Okay, that's great. But we're not printing anything. We should be printing something. Should we? Isn't it? Is it because we're not in range? Latitude is greater than min latitude. Okay. And longitude is greater than min longitude. Oh, our longitude is actually out of range. Okay, let's try it again. 29, negative 65. Okay, good. And that's asking us again. 29, negative 66. Okay, good. And something out of range. Let's do 23. That's within min. And then let's do negative 50. I think that's too much. And then this should be quiet. Great. So I think we have our program here. F-get-s and scanf. So that's our program. So here's our basic program. Again, declare these variables to store values in every single time, right? And then after that, we're going to declare a buffer for our line, our CSV line. We're going to initialize a variable that tells us how many items we read. Then we're going to infinitely loop. We're going to get the current line from standard in, right? So from the user. Then once we get the current line, we're going to do scanf to get the values with that current line. Put the values into wherever address of latitude, longitude, and data are. Return back the number of items read. If the items read is less than 3, meaning that we didn't get all of these values, we'll break from the loop. So that ends the program. Or that doesn't end the program, it will just, yeah, it should end the program. We didn't test that. Let's test it real quick. I forgot. We didn't even. Yeah, it should end the program. Yeah. So that's what that we only read 2. So that ends the program. But otherwise, we'll check to see if the inputs, right, match this rectangle. And if it doesn't print anything. Otherwise, it'll print out what we need into standard out, which then we can use to feed into our CSV to JSON. Okay. So we don't really need this right here. We already got this program down, right? So it's similar, except we did it the cool way. We use fgetS and scanf for that. Okay. So test drive. So, we can download the spooky CSV file. Let's see. Oh, we can't. Let's actually look for it. The internet's good. Spooky CSV head first C. There we go. Spooky CSV raw file. Nice. Okay, so we got it from the internet. The internet has everything permanent. So don't ever put stuff that you don't want people to see on the internet, like these videos. Data.csv from Bermuda. Okay, so we'll name the same thing data.csv, but it's under Bermuda. So if we do that, we can just do a.out data.csv, and we should get stuff here. Okay. Oh, at some point we should probably kill the program, huh? Oh, I know why. Because we don't have a new line. So, try that again. We should have a case for new lines, but for now. Uh-oh. Why didn't that work? Okay. So, there is something wrong. Our program should kind of, I guess, end, right? So I think we should check to see if it's the end of the file. So maybe an easy way to do this is in our Bermuda, we should probably check to see how many characters were read. Maybe this function. Yeah, let's do that. So how do we do that? Did we just see if we read anything? And then we'll just account for it? Maybe? So CSV line. And then we'll just do this. Okay. Oh, this is garbage. Wait, no, it's not. So we read all this. Elvis, Elvis, Elvis. So that's the last line here. Elvis. 27, whatever, whatever. So it just keeps infinitely going. And so what do? It keeps reading the same thing. Should we at least... What do we do? What do we do? Let's have a blank line. Let's see what happens. Okay, so we read nothing. Should we just do that for now? Yeah, let's figure out what's going on later. Let's just do that for now. Let's just have a blank line at the end to get it to not read or not go on forever. It's called end of file actually, but I just don't know how to do that right now. At least I don't know how to do that in C. So we'll figure it out next time. But let's just add a new line, like an extra new line here to make it go away. And I think our tool should work like that nicely. So these are all the valid Bermuda points. Okay. Now let's see what happens if we run our program like this. Okay. So what we need to do is do something similar. So we're going to do a dot out. We're going to pipe the result to, I guess we need our full path. C lat long, what do we have? CSV to JSON, a dot out. And then we're going to pipe in data.csv. And then we're going to do output.json. Okay, so that seems to have worked. So basically, we run our program in Bermuda. So this is the Bermuda program. And then we run our CSV to JSON, right? But then this input here will only input, see this redirection for a standard in. That actually only considers the a.out, right? That will put it into a.out. And then whatever output will then output to output.json. So let's check it out. And looks like we were able to convert it. Looks good. So I ran out of time. I gotta go off now, but I'll continue this tomorrow.